Sotade Olusegun. In today's particular live session, I'm going to actually share with us the true nature of time, light, and mass. And this is going to be the part two of the previous version titled part one. So I uploaded one live session earlier before this one. It was titled The True Nature of Time, Light, and Mass as Revealed by Formula of Everything, part one. So this is going to be the part two to that. So now, in that part one, I had discussed the definition of energy, mass, and that of the time. Actually, I stopped at this time energy wave model. I was actually trying to explain this time energy wave model to, drive my point home. So now what I'm going to do is just to quickly give you the rundown analysis of what I, discussed in part one. In part one, I was like trying to, open our eyes to what the nature of energy is. And we know that when we try to quantify energy, to something we can actually see with our eyes, that is going to be light. And basically, we know electromagnetic wave gives light. And right now, we know that electricity and the light, they are, the same thing. So now, the thing is, we have, the likes of Albert Einstein, Michael Faraday, James Maxwell. They all worked on, the nature of light. And Maxwell, he said, light can never be static. So that is just to let us know that the constancy of light will always, be, we always, you know, will always be, how am I going to put it? The constancy of light will always be the same, irrespective of, where you are to light. So whether you are pushing the light or you are even moving away from the light, that will not contract light. It will neither, elongate or expand light. So we have to actually put that at the back of our mind. So light is quite different from, any other form of wave that we can think of. Basically, if you have a boat that is actually moving at a certain speed, while you are in that boat, you can actually see the propagated wave probably at the bottom of the boat, and that wave will be, static to you. Right here, we're considering the effect of relativity. Relative to you, moving at the same speed with the speed of that wave as it is, will make that wave to be static to you. But light is not like that, because if you hold a mirror and you are moving at the speed of light, you can't say that since you are moving at the speed of light and the light that will reflect from your eyes onto that mirror, that will actually, reveal your image on that mirror, cannot reach that mirror. It is never done like that. Even though you are moving at the speed of light, light will still, propagate by its constancy to reflect your face onto that mirror, and you will still see yourself. So with that, you can get to know that light, its nature is quite different. And by the time we dissect, the relationship between distance and time, we'll get to know why it is like that. And from that, we can even, get to know why the measurement of light is, two-way measurement, unlike other conventional measurements that we have to, be one-way measurement. You understand? So those are the things that we're going to really dissect in this part two. This part two is going to be quite insightful, It's going to be quite informative. Then, concerning mass, I define mass uh, to be the property of a body that causes something to have weight in a gravitational field. Well, you know, there is a way light, there is a way light interacts with energy, that it converges energy to actually form what is known as mass worth. Now, this weight in gravitational field is what we can actually refer to as mass. But the thing is it truly that we have a convergence that we can actually refer to as a mass, or do we have a repulsive force that gives sensation of, that gives that sensation of feeling solid or feeling being heavy? So those are the things that we're going to actually dissect. And when you look at what I have here as the illustrative diagram of mass, you can see that I have, a kind of spiral convergence towards the central point. I have blue, the outer layer to be in blue, while the inner layer to be in red for Earth. So what that is telling you is that the whole entirety of mass convergence is more or less like this spiral formation towards the central point. And with that, we're going to have a kind of repulsive force that we actually give that sensation of, being heavy and then being solid. But then if you look at it, you know that the outer layer of Earth is solid. But when you go to the core center of the Earth, then we're going to have this unstable fluid, you understand? And it is for this reason we could have, the eruption of lava to, give rise to earthquake and things like that. Then we have another type of mass, which is known as sun. When you look at the outer layer of that, we have it to be energy density, which will be quite unstable, and that is why we could have this solar corona, the eruption of the solar wind, you understand? So right inside we have a solid convergence. So these are the things that we need to consider. And then time, its definition is new, it's novel, based on my novel research discovery, and I call it to be the electromagnetic speed of relativity scaling. The reason I have to say the nature of time is this is for the fact that time has two identities. The first identity, when time is in its default state, time is instant. But when time is in relativistic scaling with energy, it becomes continuous. I'm going to prove this with Galileo's experiment, and we'll be able to actually dissect the relationship between distance and time, and then we'll be able to see this clearly. So now, energy, on the other hand, has two identities as well. Energy is infinite by default. It means, the ability to be everywhere. And when energy is in relativistic scaling to time, then it becomes discrete. So now, when you look at it, it is said that the speed limit of light, that is the universal speed limit. But basically, we know that we have a particular phenomenon which is known as quantum entanglement, and we know there is possibility of, transmission of information at the speed that is faster than the speed of light, which is instant. So all these are the things that we're going to explore in this video. So now let me now get back to this part 2 proper. Now the diagram that I have here is known as time energy wave model diagram. This is what I use. When you apply formula of everything is dt dm equal to capital Un plus 4m. That formula is as simple as it is, but it is so powerful because it could actually feed back on itself. And what that means is that it's a kind of formula that when you use an input, it will generate an output. Then you can actually use the generated output as input to generate further output. And then by doing that, we can actually get, uh, the major answer in the core singularity of the black hole, which is, around this place where we have the neutron star suspension. But then that formula, when it is applied, the formula can actually give us this diagram. How will it give us this diagram? The T, the M is actually referring to the inverse relationship of time to energy. But then you can see that the form of energy that we use is mass, because it is only by using mass that we can actually get to the tiniest spot in the core singularity, so as to have alignment of mass convergence to the alignment of energy curvature to have the standing wave needed that we actually project us into the complex level or into the complex system. Now, the whole quantum entanglement as we have it is a kind of relationship. Entanglement is a relationship that we have from nucleus of the substrate dimension to the nucleus of higher dimension. It's a transiting point from the nucleus of substrate dimension to the nucleus of higher dimension. Please take note of that. And so I'm going to expatiate more on that. So, but the thing is this. For instance, if you use, let's say you use this mass worth as we have it here, which is the quantum mass worth, which is 9.109 times 10 raised to power minus 31 kilogram. This is the mass worth of an electron. If you put that in the place of the two m's that we have in the formula of everything, then what you are going to get will be the classical counterpart of that quantum mass worth, and that is going to be this value, 2,277,250,000 kilogram. But then if you substitute this classical mass worth in the formula of everything, the answer that we're going to get is going to be this particular answer, which is 5.7 times 10 raised to power 48. Now, this answer that we have, if we'll expand that in standard form, then we're going to have a couple of zeros that we suspend the worth of what I call weak conveying force. Now, the 4M in the formula of everything represents the weak conveying force, while the capital UM represents, the strong conveying force. Now, the formula of everything, don't forget, I call it to be the TDM equal to capital UM plus 4M. The capital UM plus 4M is a linear solution, and that is what will actually give us this equilateral triangle. This equilateral triangle that we have nested right inside the curvature of time. This blue curvature is the curvature of time, while the red curvature is the curvature of energy. When you now expand this 5.7 in standard form, you have a couple of zero that will suspend the weak conveying force, which is the worth of that 4M at 32nd position. And then the value that we have is going to be the base worth of this electron's worth. And it is not going to be in form of 9.109. It will be in form of 9,109. So now when we now put that value, when we put it above 10 raised to power 32, because we need to manually annihilate by having this by having this value, which is 5.7 times 10 raised to power 48, we have this